Okay, so that's question, I believe that was question 3. Yeah, that was a very long question. Question 4 is asking which combination is the best choice to prepare a buffer with a pH of 9, and we have ammonia and ammonium chloride. We have CH5, CH3N, and CH3, CH5NHCl. We have nitric acid and sodium nitrite. Or sorry, we have nitrous acid. Sorry, that's not nitric acid. It's nitrous acid and sodium nitrite. And we also have HCHO2 and NaCHO2, its conjugate base. So let me just list out these guys here. So we have number 4 here. So we want a buffer with pH equals 9. And then we have here, A here would give us NH3, NH4Cl. And then we have the Kb value here. The K, or the pKb value here is for NH3 is 4.75. B here I have C5H3N and also C3H5NHCl. We know that the pKb for C5H3N here equals 8.76. C here we have nitric acid, so HNO2, and we have sodium nitrite. And we know that the pK, I believe this is the pKa here, because we're talking about the acid here, the nitrous acid here, of this is HNO3. Here is 3.33. And then finally, let me scroll down here, we have our last guy here, which is HCHO2 and NaCHO2, and then the pKa for HCHO2 is I think it's just HCHO actually. I don't think there's a 2 here. Equals 3.74. I'm trying to draw that into my mind here, and I don't think there's a 2 here at all. Same with this one. I think it's just NaCHO, I believe. Let me just check. Yeah, I think it's because oxygen is double bonded to the carbon here. So I believe that's our solution here. Yeah, make a double bond here. Okay, sweet. So we're given all 4 of these guys here, and we're making our buffer here. Right? We're talking about our buffer, and we want it to be in the range of pH 9, right? So in order for us to do that, how do we make a buffer? Well, our buffer works best here when it's at its half equivalence point, right? When pH equals half of pKa at its half equivalence point, then we know that this here would be our a great buffer here, right? Because our buffer here, it only tolerates a pH change of plus or minus 1, right? So buffer only works when our pH, it's going to resist change when it's plus or minus 1 here, right? So we care about that. And we also know that pH here equals pKa at half equivalence point. So at half EQ point here. So we know that it has to. So these 2 conditions have to be met here in order for us to get a buffer, or to have a buffer of pH 9 here. And we care about this pH 9 here because pH 9 here basically has to equal very close to our pKa value as well. So basically what I would do to these questions, I would convert all of these guys here into pKa. So and I want pH equals pKa. So you can assume that if I want a buffer of pH 9, my pKa also has to equal 9 here. So immediately I can take off C and D here, because my pKa here is obviously 3 and 3.74. So these 2 are not correct answers. not even close to 9 here. And then for these guys here, I would need to convert KA into, KB into KA, right? So I know here that 14, or PKW here, PKW equals PKA plus PKB, and that has to equal 14, right? So in this case here, I know that PKA has to equal 14 minus 4.75. This here will give me a value of 14 minus 4.75 would give me a value of, this is 9.25 here. And then for this one here, it's 14 minus 8.76 here, which would give me a value of 8.76, give me a value of 5.24 here. It's 5.24. So this here would be our pKa of both our buffers here, right? So this here is the pKa. So as you can see, which one's closest to 9? A is closest to 9, right? So again, 9.25 is very, very close to 9 here. So the buffer that will be made here will be the ammonia and ammonium chloride would be best. 5.24 is no way close to 9 as well. So number 8, so A here is correct because, again, you need to know the relationship between pH and pKa, and you have to know that the pH has a tolerance of plus or minus 1 pH, right? Remember, pH here is a it goes by a logarithmic scale, so it's the ratio is from 0.10 all the way up to 10, like so here. The ratio of concentration of conjugate base to the acid must be approximately in the range of 0.10 to 10, or you can say from the pH between plus or minus 1 here, and the buffer can act effectively on each side here. So we care about that here, and it says a buffer works best if concentration of acid and base is equal. So concentration of acid and the base here have to be equal, so in order for us to get a good buffer here. So in order they've calculated probably the pKa of those guys here, and they realize that pH equals pKa at half equivalence point. So we know that the pKa of A here is 9.25, which means it's going to make our best buffer here. So the solution, again, they said therefore option A is correct. So solution is correct, but I think they're missing. But no analysis really shown for the calculations of pKa values for all 4 options here. So I'm going to say solution here is correct.